Welcome to Section 3, Best Practices for Building Solutions on AWS. As you design a solution, think carefully about trade-offs so you can select the best approach for your needs. For example, you might trade consistency, durability, and space for time and latency to deliver higher performance. Or you might prioritize speed to market over cost. Trade-offs can increase the cost and complexity of your architecture, so your design decisions should be based on empirical data that you obtain from testing, such as load testing or benchmarking. In this section, you will learn about the best practices for designing solutions on AWS. You will also learn about anti-patterns or bad solution designs to avoid. When you run your workloads on the AWS cloud, you can scale your infrastructure quickly and proactively. It's a best practice to implement scalability at every layer of your infrastructure. To understand the importance of scalability, consider this anti-pattern, where scaling is done reactively and manually. In this scenario, when an application servers reach full capacity, users can't access the application. Administrators then manually launch one or more new instances to manage the load. Unfortunately, it takes a few minutes for an instance to become available for use after it's launched. This strategy lowers the availability of your application. By enabling scalability, you can improve your design to anticipate the need for more capacity and deliver it before it's too late. For example, you can use a monitoring solution like Amazon CloudWatch to trigger the resource scaling that's needed based on a threshold that you specify, such as CPU utilization greater than 60% for longer than 5 minutes. With CloudWatch, you can also design custom metrics. When an alarm is triggered, Amazon EC2 autoscaling immediately launches a new instance. That instance is then ready before capacity is reached, which maintains availability. You also want to design your system to scale in. When demand drops off, you can release resources you no longer need to lower cost and complexity. The next best practice is to automate your environment. AWS offers built-in monitoring and automation tools at virtually every layer of your infrastructure. By using these tools, your infrastructure can respond quickly to changes. You can use tools like CloudWatch and Amazon EC2 autoscaling to detect unhealthy resources and automate the launch of replacement resources. You can also be notified when resource allocations change. The third best practice is to treat your resources as disposable. Before virtualization and cloud computing, adding new hardware meant adding a new physical resource. With this model, it's easy to buy more specific components than you need to prepare for spikes in usage. Provisioning for peak usage is expensive and inflexible. Instead, in the cloud environment, you use services instead of physical assets. In this model, you treat your resources as disposable, easy to create, delete, and reconfigure. Migrating between instances or other discrete resources is fairly straightforward. You can quickly respond to changes in capacity needs, upgrade applications, and manage the underlying software. The fourth best practice is to use loosely coupled components. Traditional infrastructures have chains of tightly integrated servers, and each one has a specific purpose. The problem is, disruption to the system can be fatal when one component or layer goes down. It also impedes scaling. If you add or remove servers at one layer, you must also connect every server on each connecting layer. With loose coupling, you use managed solutions as intermediaries, such as load balancers and message queues, between the layers of your system. With this design, the intermediary automatically handles both failures and scaling components or layers. The example on the right shows a load balancer that routes requests between the web servers and the application servers. If one application server goes down, the load balancer automatically starts directing all traffic to the two healthy servers. The next best practice is to design services, not servers. For example, take Amazon Elastic Compute Cloud, or Amazon EC2. Although EC2 offers tremendous flexibility for designing and implementing your solution, it shouldn't be the only solution you use. In some cases, containers or serverless solutions are more appropriate. It's important to consider which solution is most appropriate to your needs. With AWS serverless solutions and managed services, you don't need to provision, configure, and manage your EC2 instances. Managed solutions can replace server-based solutions at a lower cost. A few examples are AWS Lambda, Amazon Simple Queue Service, Amazon DynamoDB, Elastic Load Balancing, Amazon Simple Email Service, and Amazon Cognito. The sixth best practice is to understand the requirements of your workload and select a database solution that supports those requirements. In traditional data centers and on-premises environments, the limits on available hardware and licenses can constrain your choice of a data store solution. We recommend that you choose a data store based on your application environment's needs. Where possible, eliminate single points of failure in your architecture. This simple system shows two application servers connected to a single database server. The database server represents a single point of failure. When it goes down, the application servers also go down. This should be avoided. Application servers should continue to function even if the underlying physical hardware fails, is removed, or is replaced. This doesn't mean that you always need to duplicate every component. Depending on your downtime service level agreements, you can use automated solutions that only launch components when needed. You can also use a managed service where AWS automatically replaces malfunctioning underlying hardware for you. To eliminate the single point of failure in the example we just looked at, you can create a secondary or standby database server and replicate the data. If the main database server goes offline, the application servers automatically send their requests to the secondary database. With cloud computing, you can trade capital expense for variable expense. Capital expenses are also known as CapEx. This refers to funds that a company uses to acquire, upgrade, and maintain physical assets, such as property, industrial buildings, or equipment. Under this model, you pay for the servers in the data center, whether they are active or not. By contrast, AWS services use a variable expense cost model. This means you pay only for the individual services you need for as long as you use them. Within each service, you can optimize for cost. Many services offer different pricing tiers, models, or configurations. Keep in mind that it can be expensive to replicate an on-premises data center setup of servers running 24/7 in the cloud. So, from a cost perspective, the best way to build your infrastructure is to only provision the resources that you need and stop services when they're not being used. Caching is a technique that makes data requests faster and reduces network throughput. Caching temporarily stores reference data nearby because it might be needed again. In the anti-pattern example, no caching service is used with Amazon Simple Storage Service or Amazon S3. When anyone requests a file from an S3 bucket, each request takes the same amount of time to complete. Also, each request costs the same. In the best practice example, the infrastructure uses Amazon CloudFront to provide caching in front of S3. In this scenario, the initial request checks for the file in CloudFront. If it's not found, CloudFront requests the file from S3. CloudFront then stores a copy of the file at an edge location close to the user and sends a copy to the user who made the request. Subsequent requests for the file find a copy in the edge location in CloudFront instead of in S3. This reduces latency and cost. After the first request, you don't need to pay for the file to be transferred out of S3 while it's still cached in CloudFront. Security isn't only about getting through the outer boundary of your infrastructure. It also involves ensuring that your individual environments and their components are secured from each other. For example, you can create security groups for your EC2 instances that allow you to specify which ports on your instances can send and receive traffic. Security groups can also determine the source and the destination of the traffic. You can use security groups to reduce the probability that a security threat on one instance can spread to every other instance in your environment. You should take similar precautions with other services. We'll discuss specific ways you can implement this best practice throughout this course. Here are some key takeaways from this section of the module. As you design solutions, evaluate the trade-offs and base your decisions on empirical data. Another key takeaway is to follow these best practices when you design and build your architectures on AWS. You should enable scalability, automate your environment, treat resources as disposable, use loosely coupled components, design services, not servers, choose the right database solution, avoid single points of failure, optimize for cost, use caching, and finally, secure your entire infrastructure. Thanks for watching. We'll see you in the next video.